Hello everyone, how are you all? This is the last part of the first chapter number system class 9th. In this part we will learn about the exponents, right? So we have learned in the previous classes about the exponents. So this is the introduction part, or we can say here we are having some identities or laws which we use while we are doing work on exponents. So our first law is a raised to power m into a raised to power n equals to. It means these are known as bases. So when the bases are same and they are in multiplication with different powers, so we have to write once. We have to write the base once, or we can say we can take common base and we have to add the power. So it will come a raised to power m plus n. Second is a raised to power m whole raised to power n. It means we are having two different powers. So in this type of case, we have to multiply the power. So it will come a raised to power m into n. Next is a raised to power m upon a raised to power n. It means the bases are same with different powers and now they are in divide. In the first they are in multiply, now they are in divide. So in this case the powers will be subtracted. So a raised to power m minus n, right? The fourth identity or the fourth law, a raised to power m into b raised to power m. Now the bases are different, means we are having the different numbers here, but we are having the same powers. So whenever we are having this type of situation, then we have to write like this. We have to multiply the bases, right? And we can take power as common. So a into b whole raised to power m. It means whatever the power is there, we can write once only, right? Then fifth one, same situation, different bases, they are in division with same powers. Now we have to divide the bases only, a upon b, and again we can take power as common. So a upon b whole raised to power m. Then if any number is having power as 0, then its value is always equivalent to 1. Whether it is 2 raised to power 0, it is 10 raised to power 0, the answer is 1 only, right? Or it is 1999 raised to power 0, but again the answer is 1. The next, if any base is having its power in minus, so we have to write like this, and the power will change in plus. So a raised to power minus m equals to 1 upon a whole raised to power m. It means we have to write the reciprocal of the base, right? But if the denominator is having its power in minus, then again we have to reciprocate, or we have to write as reciprocal. So the reciprocal of 1 upon a will become a, and power will change into positive. So 1 upon a raised to power minus m equals to a raised to power m. Or we can understand by like this, if it is 2 raised to power minus 5, so we can write like this, 2 raised to power 5, right? Or in the previous one, if it is 2 raised to power minus 5, so we can write down like this, 1 upon 2 raised to power 5. Clear? Then the ninth one, if nth root of a is there, so we can write down like this, 1 upon n. It means if we are having square root of 7, so we can write down 7 raised to power 1 by 2, right? Or if it is like this, cube root of 19, right? So we can write down like this, 19 raised to power 1 by 3. So it means if we are having any root, then we can write like this in the fraction form. Then if we are having a raised to power m upon n, it means if the power is in fraction, so the denominator represents the nth root. So we can write down like this. So nth root of a whole raised to power m. It means whatever the number is there, it will become the square root or the cube root. It means the nth root, and whatever the numerator is there, that will become the whole power. Or we can write down like this also, nth root of a raised to power m, right? Okay, so now we will move towards the exercise of exercise 1.6, right? So question number 1, find First question is having 3 parts. So first part is 64 raised to power 1 upon 2. Or we all know that 64 is the square of 8. So in place of 64 we can write down 8 square whole raised to power 1 upon 2. Now it is just like identity number 2, you can see. A raised to power m whole raised to power n. We have to multiply the powers. And same we have to do here. We have to multiply the powers. 2 into 1 upon 2 like this. Right? And when we are having this type of number, so we can cancel them. And only 1 is left, 8 raised to power 1, or we can say it is 8 only. Similarly, we have to solve the second one, 32 raised to power 1 upon 5. We all know if we factorize 32, so it will become 2 raised to power 5. Right? So it means how we can factorize 32? We can factorize 32 like this. 2, it will come 16, again 2, it will come 8, then again 2, it will come 4, again 2, it will come 2, and again 2, it will come 1. It means 1, 2, 3, 4, 5. So we can say 2 raised to power 5 equals to 32. So, or in place of 32, we can write 2 raised to power 5. Same we have to do here. 32, in place of this, we have write 2 raised to power 5. 1 upon 5, we can write down here 1 upon 5. And again use the second identity, second law, equals to 2 into 5 raised to power 5 into 1 upon 5. Again we can cancel 5 and 5, right? Or equals to 2 raised to power 1 or 2. Then C part, 125 raised to power 1 upon 3. Again factorize 125, write down the factors in the form of 5 raised to power 3, 1 upon 3. We have to write outside the bracket. Again multiply them, cancel 3 by 3. And 1 will be there, so 5. Right? Question number second, again find. So 9 raised to power 3 upon 2. This is the first part. So we can write 9 in the form of 3 square. 3 3 is a 9. So 3 square, right? And this power we can write outside the bracket. Again use the second law. It means 2 into 3 upon 2. Or we can cancel 2 and 2. So 3 raised to power 3. Or when we multiply 3 into 3 into 3, the answer is 27. Right? Then 32. Again 2 raised to power 5. Again we have to multiply the powers. 5 into 2 upon 5. Cancel them. Right? So 2 raised to power 2 or 2 2s are 4. Then 16 raised to power 3 by 4. 16 we can write in the form of 2 raised to power 4. Right? Or into 3 upon 4. Again we can cancel 4 by 4 or 2 raised to power 3, which is 8. 2 2s are 4. 4 2s are 8. Right? Then the D part, 125 raised to power minus 1 upon 3. Right? Now we have to use the identity number 7. A raised to power minus m. So how we can write? If the number is having minus power, we have to write like this. So same we have to do here. It is 125 raised to power minus 1 upon 3. So we have to write like this and the power will change in plus. Right? Now 125, how we can write? 5 raised to power 3. Again do the same thing, 5 raised to power 3 into 1 upon 3. Right? Again cancel 3 by 3 and you can get 5 raised to power 1 or we can say 1 upon 5. Right? Now question number 3. 2 raised to power 2 upon 3 dot means multiply into 2 raised to power 1 upon 5. Use the identity number first. When the bases are same and they are in multiply with different powers, so we have to add the powers. So same thing we have to do here. 2 raised to power 2 upon 3 into 2 raised to power 1 upon 5. Write down 2 ones because it is a common base and add the powers 2 upon 3 plus 1 upon 5. Take the LCM. Right? So you can take the LCM here. So it will be 15. The LCM of 3 and 5 is 15. Right? And when you just compare the numerators, in the table of 3, how many times is 15 comes? 5 times, then 5 2s are 10. Plus sign, put the plus sign here. In the table of 5, how many times is 15 comes? 3 times, then 3 1s are 3. And 10 plus 3 is 13 upon 15. So this is the answer, 2 raised to power 13 upon 15. Second part, 1 upon 3 raised to power 3 whole raised to power 7. So this, whenever we are having the whole raised to power, it means this power is with the numerator as well as this power is with the denominator, right? So we have to use the second law. So 1 raised to power 7 and 3 raised to power 3 into 7, and 3 sevens are 21, right? So it will come 1 upon 3 raised to power 21. Third part, same basis, they are in division with different powers. It means now we have to use the identity number 3 or the law 3, third law, right? So 11 raised to power 1 upon 2 whole upon 11 raised to power 1 upon 4 equals to, we have to write the base once. 11 is same, so we can take common, and we have to subtract the powers 1 upon 2 minus 1 upon 4. Take the LCM, 4 will be there. In the table of 2, how many times this 4 comes? 2 times. Then we have to multiply that 2 with the numerator, which is 1. So 2 ones are 2 minus, put minus sign here. In the table of 4, how many times 4 comes? 1 time, and 1 ones are 1. It means 2 minus 1 will become 1 upon 4. So 11 raised to power 1 upon 4. And the last one, fourth part, 7 raised to power 1 upon 2 into 8 raised to power 1 upon 2, right? Now the bases are different with the same powers in multiplication. It means we have to use the fourth law. So we have to multiply the bases only, and we can take the power as common. So 7 to 8 whole raised to power 1 upon 2, 7 8s are 56 whole raised to power 1 upon 2, right? Hope again this video is helpful for you people. If any comment or suggestions are from your side, then please give it. Please like, and if you didn't subscribe my channel, then please do it, and share the video as maximum. You can share it with the maximum number of students, then please share it. Thank you very much.